Hello, welcome to week 3. In week 3, we are going to cover 1.6, the last section in chapter 1, and then we're going to jump into chapter 2, skip over 2.1, and go to 2.2. 1.6 covers rational expressions. I don't know if you noticed, but in section 1.4, when we talked about polynomials, we added, subtracted, multiplied, but we did not divide polynomials. That's what we do when we have a rational expression. It divides polynomials. Here's an example. We've got x squared minus 4 in the numerator divided by, in the denominator, x squared plus 5x plus 6. This is an example of a rational expression where we have a polynomial in the numerator and the denominator. Now, rational expressions work a lot like fractions, and we're going to do operations with rational expressions, and we're going to simplify rational expressions. Let's visit fractions and remind ourselves of some of the basics about how fractions work. So first of all, we can simplify a fraction such as 4/6. We want to reduce that fraction by any common factor that we can. We can rewrite that 4 into the factors of 2 times 2. We can rewrite the 6 as 2 times 3. Now, 2 divided by 2, 2 over 2, that's just equal to 1. Any non-zero number over itself is just equal to 1. So when that shows up in a fraction, that means that we can cancel those out. And we are left with the simplified fraction of 2/3. Another thing that we can do with fractions and then rational expressions is multiply. Let's take 2/5 times 15 over 14. Now, to multiply fractions, we multiply across the numerator, multiply across the denominator. We always want to simplify. But here's a key, and this is even more important when we're looking at rational expressions. We want to simplify first. It makes our life so much easier. If we do this now, 2 times 15, okay, we know that's 30. But 5 times 14, I'd have to get out my calculator. I don't necessarily want to do that, but we can simplify first and make this an easier problem. So let's factor the numerators and denominators if possible. So the 2 isn't going to factor, we leave that. The 5 doesn't factor, but 15 we can write as 5 times 3. The 14 we can write as 2 times 7. Now, the numerator and denominator does not share a common factor, but we can look across the multiplication. There is a 5 in this denominator, a 5 in this numerator. We can cancel those out, and it leaves a 1 in its place. Same thing with the 2 here and the 2 here. We can cancel those out. It leaves a 1 in its place. Now, when we multiply across the numerator, we are multiplying 1 times 3 to get 3, and the denominator 1 times 7 to get 7. A much easier multiplication than we had to begin with. So simplifying before multiplying is always going to be helpful, especially when we're looking at rational expressions. Divide polynomials. That's what we do when we are also going to look at adding and subtracting rational expressions. So let's revisit how we add and subtract fractions before we start to use polynomials in the numerator and denominator. Here we need to have the common denominator. Notice when we multiplied, we didn't say one thing about having a common denominator, but for adding and also subtracting, we now need to have both fractions have the same denominator. We don't have that with these two fractions. We have a denominator of 2 and we have a denominator of 3. So they need to share those factors of 2 and 3. This one does not have the 3, so we are going to give it a 3 by multiplying that denominator of 2 by 3. Now, if we do that, we have got to balance it out by multiplying the numerator by 3 as well. Again, remember, any non-zero number over itself is just 1. We can multiply anything by 1 and it doesn't change. This one is going to need to have a factor of 2. So let's multiply this fraction in the numerator and denominator by 2. So that gives us 3 times 5, which is 15, over 3 times 2, which is 6, plus 2 times 7, which is 14, over 2 times 3, which is 6. There's our common denominator of 6. That is done. We're done with the denominator. And now we add across the top. 15 plus 14 gives us 29. Now maybe you're wondering, do we want to change that from an improper fraction? We get to leave it. We can leave it just like that. We don't need to make it a mixed number. We don't need to plug it into our calculator. This is a perfectly acceptable answer. 4 in the numerator divided by in the denominator. This week we're going to dive into chapter 2, and we're skipping to section 2.2 because that is where we start solving equations. Up to this point, we have not been able to solve for our unknown. We have not been able to solve for our variable. And that's because we haven't started off with equations. We've only had expressions such as 3x minus 2. That is an expression. It is a combination of numbers, variables, and operations. There's no equal sign. But if we set that equal to another expression, we now have an equation and we can solve for that unknown. We can solve for that variable. So to solve the equation, we want to solve for the variable. A lot of times it's x. Other ways to put that is to get x by itself or to isolate x. And how we do that is undo the operations that surround those variable x, or surround that variable x. So let's give it a try. X shows up in 2 places. So first thing we want to do is get it on the same side. So we're going to subtract 5x. We can do whatever we want as long as we do it on both sides. We got to keep it in balance because we have that equal sign. 3x minus 5x, we get negative 2x minus 2 equals 5x minus 5x, no more x's, but it's equal to 3. We want to undo the operations around this x now. So we'll add 2 to both sides. So we get negative 2x equals 5. And then finally, we want to undo this multiplication of x and negative 2. To undo the multiplication, we divide. That gives us these two negative 2's canceling, and x is by itself on one side of the equal sign equaling 5 halves. This is one of the more basic equations that we are going to look at in this chapter. Section 2.1 or 2.2, section 2.2 is going to cover what we call linear equations. So what makes an equation linear? A linear equation has degree of 1. Remember what degree is. Degree is the highest exponent in an equation. So, for example, 2x plus 1 equals 5x minus 1. We have x showing up twice. Both of them have an exponent of 1. No exponent implies that it's 1. They both have degree of 1. Some of the basics about how linear equations in this section are going to show up in other ways that might not look like they're linear. For example, 1/3 plus 1/2 x equals 4/3. This is a linear equation. Remember, it's the x and the exponent on x. This is a linear equation. Another example of a linear equation that we're going to encounter in this section is when x is trapped inside parentheses, such as 5 times this quantity x minus 2 plus 3 equals -4 times x plus 1. Also linear. Okay? So x shows up on both sides, but both of them have degree 1. And we will solve that like we solve other linear equations, getting x by itself on one side, undoing the operations. Okay, so that's this week, 1.6 and 2.2. Now you get to dive into the video lectures where we'll go in more depth on rational expressions and solving linear equations. You'll have practice problems and your XYZ homework.